If there is one single individual who inspired me during my whole life, it is Michael Crichton, the author of this book, Jurassic Park. He was such a powerful storyteller who popularized topics not only like paleontology, but also nanotechnology, genetic engineering, quantum physics, in a way that no one else did. He not only celebrated the novelty, the technological innovation, but also highlighted the dangers of innovation. You can see that very much in the agenda of Brainbar and the DNA of this festival. My favorite is Jurassic Park because it shows very well what could go wrong if humans are trying to play God. Unfortunately, I cannot invite Michael Crichton to Brainbar. He's long gone. But you know what? There is someone very much alive who inspired the man who inspired me. So, ladies and gentlemen, please give a warm welcome to the master scientist behind Jurassic Park, straight out from the bedrocks of Montana, Professor Jack Horner.
Well, I was told I had a young audience. How many 8-year-olds are there? Do you remember when you were 8? Do you remember liking dinosaurs? Would you like to have a pet dinosaur? There's 5 people that want a pet dinosaur. Why am I here? I'm willing to bet that very few of you even know what a dinosaur is or what they might actually look like. How many people did not see Jurassic Park? 5. Okay. Why not? Well, you're going to need to know a little bit about Jurassic Park for this talk. Will dinosaurs roam our future world? It was long thought that dinosaurs had roamed the world for 160 million years. And that, after 160 million years, they all died off. They went extinct. That's what people thought about dinosaurs for a really long time. But now, people actually know, most people know, that dinosaurs dominated the Earth for 220 million years and are still here because birds are living dinosaurs. Do you know that? Do you also realize that that means that birds are reptiles? Birds are reptiles. How many people have a hard time with that? They're all in the back. So everybody up front is okay with the fact that birds are reptiles, right? Okay, good. So we paleontologists separate the dinosaurs now into 2 categories. We call them avian dinosaurs, the ones that are with us, and non-avian dinosaurs. And the non-avian dinosaurs, well, we know what happened to them, right? So the non-avian dinosaurs went extinct, and the avian dinosaurs survived and evolved. And they are with us today. So all birds, and I mean all of them, are dinosaurs. We can't test it genetically, but we at least can look at our modern reptiles and test them genetically, and what we discover is that crocodilians, alligators and crocodiles, are actually more closely related to birds than they are to lizards, snakes, or turtles. So this is the answer, right? Avian dinosaurs will roam the future world. Are we done? All right, so I suspect you're like the 8th graders. You don't care about that. The birds are great. You want to know whether non-avian dinosaurs will rule or roam the future world. Is that correct? Is that what you want to know? All right. So that brings up Jurassic Park, right? So in Jurassic Park, that's just exactly what Michael Crichton did. Michael Crichton imagined a way to actually bring dinosaurs to our modern world from extinction. So basically, as you know, the story, all you have to do is find some amber, find an insect, a blood-sucking insect inside the amber, and you just suck the DNA out and clone it, and wait a while. You got some dinosaurs. And, you populate the world with them, or at least you populate your park with them. You get some cool dinosaurs, really cool dinosaurs. And, of course, not only are they cool looking, and not only are they in your park, but, they escape, of course, and they go chasing people. And that's basically Michael Crichton and Steven Spielberg's story, right? Dinosaurs love to eat people, right? They will break into your house. They will tear your vehicle apart. They will do anything to eat a person, right? That's a Steven Spielberg kind of movie, right? For a long time, he was selling the idea that a big shark would eat a boat just to get to a guy, right? Is there anybody that saw Jurassic World that's over 8? Did you notice they were still eating people? This is Indominus Rex here. Indominus Rex. I actually got to work on that one. I made it so it, basically only could eat people. I mean, it's a genetically modified dinosaur, so I could say that its diet was anything, and of course its diet is guys. You ever notice that women didn't get eaten in Jurassic Park movies? Yeah, we always had to find a bunch of guys that either couldn't run very fast or weren't very smart. They couldn't catch kids either. All right, so that's Jurassic Park, but I assume you all know that we really can't do that. We actually have tried, though. I mean, we actually have tried to do the kind of thing that Michael Crichton suggested. For about 10 years, I actually had grants with one of my former students. We had grants from the government to try to get DNA out of a dinosaur. We tried to get it out of amber. We tried to get it out of insects. And do you notice the date the government started giving us money? Somehow coincided with the movie. We couldn't get it any other time. There's something weird there, but I won't go into it. All right, so one of the things that we were able to do, we did not find DNA, but we found intact cells, we found blood vessels, we found heme, which is the foundation of hemoglobin, we found protein, but we didn't find DNA. So, we're not going to make dinosaurs. But let me just tell you, you see these dinosaurs here? This is our idea of dinosaurs, right? This is what they should look like, because this is what they look like in the movies. And does everybody realize that that's not what they look like? Dinosaurs didn't look like this. Remember, dinosaurs, non-avian dinosaurs, gave rise to birds. So we know now that meat-eating dinosaurs were all feathered. They were feathered animals, just like birds. And we're also finding fossilized melanosomes. We're starting to learn the colors of dinosaurs. And one of the cool things is that they're vividly colored. And they should be, right? They're not gray and brown. They do not look like velociraptors in Jurassic Park. Now, this is what we think dinosaurs look like now. How many people are laughing? Put your hands up if you're laughing. Yeah, everybody's laughing, see? All right, so it looks silly, right? We know that dinosaurs, the meat-eating dinosaurs like Velociraptor, were feathered. They were feathered, and they were colorful. So if we look at avian dinosaurs, we see these beautiful colors, vivid coloration. And what are avian dinosaurs? Avian dinosaurs are genetically modified non-avian dinosaurs, right? Birds are genetically modified non-avian dinosaurs. Genetically modified through the course of evolution. All right? Okay. So just keep that in mind. This is what I think dinosaurs should look like. This is Tyrannosaurus rex and Triceratops Jack Horner version. Everybody's laughing again, see? We have a paradigm shift here we need to take care of before we start thinking about whether we want dinosaurs back again, right? This is what I need to convince you of first, is that this is actually the way dinosaurs most likely looked. And I'm serious. The evidence points to this. And yet when I go to a bunch of sixth graders and tell them that, you know, Tyrannosaurus rex could have been feathered and pink, well, they throw things at me. I mean, they're not happy at all. Can we artificially, genetically modify living animals? If we're going to try to bring dinosaurs back, non-avian dinosaurs, we're going to try to bring them back, we need to genetically modify animals because we do not have their DNA. So can we do that? Yes, absolutely. We do it all the time. This is a horrible example. You know, they started with a wolf, and they've somehow managed to genetically make a Pekingese. Now that is artificial genetic modification, and it's scary. Do you see that X-ray? I mean, look at that thing. That's a full-grown dog. Something's wrong with its backbone, something's wrong with its legs, and yet we humans think this is okay. A whole bunch of people have pet ones. All right. A Pekingese dog is a genetically modified organism, right? It's a GMO. So here are some GMO chickens. What do you think? Pretty cool, eh? Mm-hmm. So here are the ways, these are biological modification methods. These are the ways that we can actually alter how animals look. We can do it through conventional breeding, which is how we make a Pekingese dog. We can use transgenic engineering, where we take the genes out of one animal and put them in another one. We make glowfish. We have modulation engineering, where we just knock some genes out and make knockout mice for laboratories. Now we have CRISPR-Cas9 gene editing, where we can knock genes out and knock genes in, which is a really cool method of altering animals. We also have atavistic gene activation, and this is actually turning on genes that have been turned off during the course of evolution. And then we also have cytoplasmic hybridization, and I'm not going there because that can be really weird, right? So this is where we take some cells of humans oftentimes and cells of other kinds of animals and put them together. I won't go there. We're not going to make a dinosaur that way. Here is the skeleton of a non-avian dinosaur and an avian dinosaur, a chicken. This is the course of evolution from non-avian dinosaurs to avian dinosaurs, and what we want to do is reverse that and see if we can make a non-avian dinosaur out of an avian dinosaur. So I have a laboratory, and we are working on this. And basically what we're doing is one egg at a time. We're not trying to make a whole bunch of them at once. We're trying to make one at a time. Basically, the geneticists go into the egg, and they put markers into the embryo and determine what genes are turning on at what time and what stage, and then see if they can alter it and have it occur at different times. And we're interested in looking at and trying to alter the arms and hands and the tail and so forth. Primarily what we're interested in is atavistic gene activation. We want to find those genes that have been turned off during evolution and see if we can turn them back on again and get something that looks like a dinosaur. So in 2006, a guy named Matthew Harris actually did this. He was able to actually initiate tooth growth in a chicken because of an atavistic gene. So this is proof of concept. This is how we know we could actually do this. In 2014, our laboratory started working on the tail, and we learned a lot of things about the tail, but we were not able to find an atavistic gene. So we're still working on the tail. In 2015, a laboratory group at Yale University was able to actually alter the shape of the head of a bird to look more like a dinosaur. Right now, they don't hatch these. These are not hatched animals yet, and I wouldn't hatch one until I got everything I wanted. So there's another group in Chile that has been working on legs, and they have figured out a way to alter a chicken's leg and foot to make it look more like a dinosaur. So, and then this last year, our lab figured out that we figured out for sure that we couldn't do it with atavistic genes, but now we think we might be able to do it with CRISPR-Cas9. So that's our next project. All right, we have figured out, we did find an atavistic gene for the hands, so we actually can make a bird right now with arms and hands rather than wings. Okay, so this is basically where we are right now. We could make a dinosaur-like head. We can make a three-fingered hand. We have the capability of making a dinosaur-like foot, and the teeth. They unfortunately are lethal. So that means that we can initiate their growth, but then they kill the embryo, and so we have to figure that one out. Right now, we're trying to lengthen the tail. So that is where we are in making our dino chicken right now. And so we come back to this question, will non-avian dinosaurs roam the future world? Before I tell you what my answer is, let me give you a sort of an animal perspective. Let's think about the animals we already have, right? We've got this one group of animals on the left here, right? They are the animals that we really like. We would love to keep them, but they're going extinct, right? We're trying to keep them alive, but they're probably all going to end up in zoos. And then we have another group of animals that have evolved and adapted to live with us, and we don't like them, so we shoot them. And then we have the animals that we truly love, right? And they're all GMOs. Our cats and dogs and chickens and cows and so forth, these are the animals we love. And so I say, you know, if we have a whole bunch that we really like and we can't take care of them, and we got a bunch that love us but we hate so we shoot, and then a third group that we love and take care of, why don't we make some more that we love? Why don't we just make the kinds we like? We talk about unicorns all the time. Why don't we make unicorns? And little kids like dinosaurs. You might not want a dinosaur, but I can tell you the sixth graders want dinosaurs. So I say, why don't we just start making some? We've got all the methods to do that. So I take you back to the dog again, right? Because we have gone from the wolf not only to a Pekingese to that thing on the right-hand side in the middle. Does anyone in this world know what that is? That is an alien. That is an alien. So if we can do this, I just can't imagine why we can't do that, right? I mean, there's nothing weirder than what we already have, right? So we also do this to chickens. Can you imagine how embarrassed that one on the right must be? A featherless chicken. My goodness. Well, so I think that when we actually get into making these animals, this is basically what we will be able to make. And the first time we try to make a dino chicken, it's probably going to look like a chicken with arms and hands and a long tail. My thinking is that it's not bad enough looking that it might be okay. Is everybody okay with a chicken that just has a long tail and little hands, just little hands? And I mean, if you just come right straight out of the gate with a full-blown dinosaur, it might be too much, right? But maybe if you start with a little dino chicken that looks like a chicken and still tastes like a chicken. So if it still tastes like a chicken, it probably still is a chicken. And then by the second version, then we could alter the head, lengthen the arms. All of these things are possible to do right now, but we would just save them, so we do them later. When we have an animal like this, then we actually could go that one step farther and make a scary one. I was the technical advisor for all of Jurassic Park movies. I was Steven Spielberg's technical advisor. And I told him, this is what Velociraptor should look like. And he looked at it and he laughed at me. And he said, Technicolor feathered dinosaurs are not scary enough. So we knew in 1993 that this is what they should look like. And what you ended up getting was, well, what you got, which they're not very bright. They're bad, they're terrible, they don't look like this, right? But this is basically what we have the capability of making as soon as we have the tail. As soon as we figure that out, we have the capability of making an animal that looks a lot like what we think a velociraptor would look like. Now, we haven't really figured out the claws. There's a lot of tinkering we need to do, but basically this is what it would look like. Now, I don't know about you, but, I think it'd be really cool to have a dinosaur. I mean, just take your dinosaur out for a walk. Everybody else has a dog that they're out walking, and you have a dinosaur. Doesn't that sound like fun? And, how about a baby Triceratops? They're pretty cool looking. Baby Triceratops would be great, right? The only problem with a baby Triceratops, of course, is that they grow really fast. And sooner or later, really sooner, they're not even going to fit in the garage, let alone the house. And of course, when they're just laying around, they're kind of an obstacle. So that would be a problem as well. And then, of course, they would probably cause traffic jams if you got the really big ones. So you know what you would have to do if you had these kinds of dinosaurs, right? You know what you have to do. You'd have to put them in a park, right? And we all know where that goes. Thank you very much.
Thank you. Thank you so much, Jack. It was wonderful. I hope you don't mind if we have a few questions for you.
All right.
Jack, you can go ahead and have the middle seat if that's all right.
All right.
And anytime I hit this buzzer, it just simply means that you swivel your chair around and take a question from the next person participating.
Okay.
All right,
All right.
so go ahead and I'll have you guys take your seats.
Hi.
Hi.
So my question is that just in case if I want a Velociraptor instead of a cat, should we domesticate it or not?
You know, whether it's domesticated or not, it probably isn't going to be domesticated, right? We're going to make it from a chicken, and it already is domesticated. So I take that back. Yes, it'll be domesticated.
Thank you very much.
This will be a stupid question for a paleontologist, but you've got a time machine, but it only's got enough juice for one return trip. Where would you go to and why?
Where would I go? You know, let me just tell you the problem with a time machine, okay? You know, if you set it on the ground and you go back, let's just say we go back 80 million years and I want to see like Maiasaura, one of the dinosaurs I named, and we're off by let's say, you know, 1,000 years, which we can't even measure, we could be buried under 1,000 feet of rock. That would be scary, right? So our time machine, we're going to have to put it somewhere else.
Hi.
Hello.
Are there any or many ethical and moral oppositions and barriers that you have to face during these experiments that hinder the research, or is it like an easier procedure?
I know this will be controversial, but you know, generally, we scientists like to think that science should move forward regardless of ethics, right? And ethics is something for lawyers, right? I mean, we need to know what we can know. We need to discover what we can. There's a lot of people that have a lot of concerns, and I get a lot of mail from people who tell me I'm playing God, and I basically say, if there is no God, you can't play God. And if there is a God, he gave me all of these methods, and if he didn't want me making them, he shouldn't have given them to me.
Thank you.
Hello. So we can make a chicken look like a dinosaur, but can we really make it that big? Is there a gene for that?
See, that's a sixth grader question. We're going to make a dinosaur that's as tall as a chicken, and it's going to be like a Velociraptor. Isn't that enough? You want a really big one.
You showed picture with the big ones. That's why I'm...
As soon as it hatches out of its egg, it's going to eat you. I would say, let's just keep them little for a while.
Yeah, I agree.
I think what you're doing is really cool, but why not start with something that is maybe like a smaller project, more closer, like the dodo bird. It's extinct, but it's extinct far closer to us right now, so why not start with this? Wouldn't it be like a smaller project? It's like a foundation for what you're trying to do.
There actually are people that are trying to bring back some of the more recently extincted birds. But I want a pet dinosaur. I want a non-avian pet dinosaur.
Thank you.
Considering that there might be something hindering the process, and we get to a certain point, what would be the real value? Do we learn something on the way by trying, get to reverse engineer?
It's a sophisticated genetics project, and we are learning an awful lot about a lot of things. Just working on the tail, we think we've actually figured out what causes a particular genetic disease in humans. So yes, there's a lot of spin-off from it. We are just learning so much about, switching genes and things like that. I mean, a lot of it is applicable to the medical field, but again, I keep bringing it back. The geneticists that work with us, they're always saying there's all these practical things, and I'm always saying, but where's my dinosaur?
That's what I was going to say.
Yeah.
Your motivation is this.
Thank you very much.
Hello. Do you have any idea how to make your profession more appealing to the younger generations? Because children, as you said, are really into dinosaurs, but as they get older, they know the hardships of your profession and get discouraged.
I think little kids just really love dinosaurs, and then they get to be, they start maturing, and they're chasing each other, right? Most of my graduate students through the years have always said they were interested when they were kids, and that was why they became paleontologists. A lot of kids just keep science, and this project is pretty cool. I mean, it is getting a lot of kids interested in genetics and developmental biology just because they want to make a dinosaur too.
Thank you.
Hi, fascinating talk. So during the course of evolution, there must have been a whole bunch of genes that weren't just silenced, but totally lost in the chicken.
Yes.
So instead of starting from one species, wouldn't it make more sense to look at all descendants of non-avian dinosaurs and then see what are the genes that you can find in all of them, because those must be most likely the conserved genes that the dinosaurs all had, and then try to pick genes from, so take the tail from a reptile and other genes and try to build it up from different species instead of just starting from one.
But first off, all birds are related. It's called a monophyletic group, so they all have a common ancestor. So theoretically, they all have the same basic genes.
Do we have genes of the common ancestor? Because maybe going back a million years, we could get DNA.
Well, unfortunately not. I mean, the atavistic genes are the ones that we do have. The problem with trying to use other birds is just, the expense. Just a viable chicken egg, a chicken egg that somebody guarantees has a live embryo in it that we can work with, costs $5. $5. An ostrich egg costs, like $50 or $100. So, and trying to go out and find exotic birds, it would just be impossible.
How about reptiles?
Birds are reptiles. Don't forget that. Birds are reptiles.
But crocodiles have tails.
Crocodiles do have tails, and we have tried. That was one of the first experiments we tried, was knocking out the tail that is there in a bird, and then trying to get an alligator-like tail to grow on the bird, and it wasn't successful. This was quite a while ago. We have CRISPR-Cas9 now that brings up another possibility, another possible way that we might be able to do that.
Thank you.
Hey, so referring back to the picture you showed us about the dinosaur and all the different parts that are being completed are in process, and I saw that the teeth are still lethal. So is it going to be able to solve in the future? Are there any methods to solve it?
There's a couple of problems with the teeth. And one is enamel, the enamel gene is gone. We don't have that. So we're going to have to add that transgenically. And when we add that, there's a possibility that that will fix the lethal problem. So we think that there's that possibility.
Thank you.
This is my hardest question of the day. You know that, right? Yes.
My question is that can we get our DNA from what fossils? Maybe we can get it out from bones or something else.
The DNA, yeah, I tried to get DNA out of everything. I tried to get out of a T-Rex, all of the bones of a T-Rex. I tried to get out of a Triceratops. We tried to get it out of, we just, we're pretty sure that DNA just doesn't last long enough. It's a gigantic molecule and it comes apart really easy. So that's why I think we have to use chickens.
Okay.
When you're a graduate student, maybe you can figure that out. Okay?
All right. Thank you so much,
You're
Jack.
welcome.
It was a real pleasure. Thanks so much for joining us here. One more time, Jack Horner.